I'm going to dissect the empirical rule a little bit more. So remember that one standard deviation above and below the mean is 68% of the data. And if you also remember the normal distribution is symmetric, then if you put a line here in the middle, where that line is, right here, and here's a line for one standard deviation below, and here's the line for one standard deviation above. So between here and here is 68%. So that means if we divide 68% in half, we'll get 34% on each side because it's symmetric. Then we have to take the 95%, and if you take out the 68% and then divide what's left over by 2, you'll get 13.5. And then if we take the 99.7%, subtract out that 95% and divide what's left over by 2, we get 2.35%. So you can also know what chunks here, what percentage of the data they are. So we can go even further into the empirical rule and make even more specific statements. So we could say between the mean and one standard deviation above the mean is 34% of the data. We can say between one standard deviation above the mean and two standard deviations above the mean is 13.5% of the data. And we can also say that between two standard deviations above the mean and three standard deviations above the mean is 2.35% of the data. This is all for a normal distribution. So you can only be this specific for a normal distribution because it follows an exact curve, which comes from an equation that you don't need to know, but that's where this empirical rule comes from. And you can just further dissect it then just saying between one standard deviation or between above and below, or between two standard deviations above and below, or 3. You can be even more specific and dissect this normal distribution a little bit more. So if we have a standard normal curve and it has a mean mu of 0 and a standard deviation sigma of 1, then that's what's called a standard normal curve. But if you remember from before, that's just z-scores. So if you have a normal distribution of z-scores, that's what's called a standard normal curve. So just the terminology. And we'll have a z-table, and on the top it says standard normal curve. On this slide, we're going to answer this question. For a normal distribution, what is the percentage between z-scores of -2 and 1? So I'm going to draw a normal distribution here. So remember, it's mound-shaped. So something like this. Then I'm going to put a line here in the middle, put a 0, because the mean is 0 for a z-score. And put 1, 2, 3, 1, 2, 3. Doesn't have to be perfect, but we're gonna put the z-scores here. We're gonna go 3 standard deviations above and below because that's where most of the data will be. Almost all of it will be there. And now we want to know what percentage is between -2 and 1. So I'm going to draw that. So -2 is here, and 1 is here. Okay, so I want to know the area between. So it's going to be this area. So that's what we're trying to find, and we want to know the percentage, which is also the probability of being between -2 and 1, but just in percentage form. So we could also put this in kind of a proportion form if we wanted to, but this question asks for the percentage. Now I'm going to dissect this normal distribution a little bit more just to help us out. So I'm going to do it here and here. So between -1 and 1, that's 1 standard deviation below and above the mean. And you can remember from the empirical rule, that's 68%. Okay? And then if you remember from when we dissected it a little bit more, between -2 and -1 is 13.5%. Okay, but we want to know the total here. Remember, you can add and subtract these probabilities if they're in the histogram. Remember, probability equals area. So we're going to do 13. The percentage equals 13.5 plus 68, which equals 81.5%. So that is our answer. For our normal distribution, 81.5% is between z-scores of -2 and 1. Okay, what happens if you have a z-score that is not exactly 1, 2, 3, or -1, -2, or -3? It's not an exact whole number. What are you gonna do? You can't really find the probabilities. You can probably estimate it a little bit, but you're not gonna get very precise. So what we have here is a table of z-scores and their probabilities. And you can see that's called the standard normal probabilities because if you have a normal distribution and they are z-scores, then you have a standard normal distribution. Here's the table. Now, what you need to remember for the use of this table is it only gives you the probability to the left. So if you see this little diagram here, it goes from here to the left. So it gives you what is the percentile. If you remember what a percentile is the probability of scoring below that value. So the standard normal table, the z-table, gives you the probability of scoring below that z-value. And here we have the z-scores and this first column here. And then the probabilities are in the middle here. And it's kind of in, proportions instead of percentages. So if you want to make it into a percentage, then you need to move the decimal over twice. You could also use calculus to find these values if you know how to take the integral of a normal curve equation, but I'm guessing that most of you don't know how to do that. And I'm not going to expect you to do that. So you can just use this table instead.